Hello everyone, I am Sam, responsible for frontline service and technical training of equipment maintenance at reliably Intelligence. Welcome to episode 6 of series 2. The first 5 episodes were all about the stacker. Today we switch topics, the shuttle, also called the RGV. In the warehouse, the RGV is like a bus, carrying goods horizontally between aisles. It's simpler than the stacker, but because it runs back and forth on the floor, its fault rate is actually not low. So which faults are most common? Wheel wear, poor conductor rail contact, comms loss, scheduling deadlock. These are the RGV's common ailments. Today we'll take them apart one by one. 4 goals today. First, understand the RGV's basic structure and common fault types. Second, master travel system upkeep, how to judge wheel wear and when to replace. Third, learn to fix power and comms faults, the 2 most troublesome RGV problems. Fourth, understand what scheduling deadlock is and how to unlock it safely by hand. Master these 4 areas, and you can handle most RGV problems. There are 4 main RGV types. Rail type is the most common, running back and forth on a fixed track. The loop type is efficient, running several cars at once, but its scheduling is complex. Through type is for long-distance transport. Lift type docks at different floors. Note that whatever the type, the core systems are similar. The travel system is the most fault-prone, wheels and track wear. The power system is critical too, and the moment the conductor rail makes poor contact, the RGV is dead. Comms problems make the RGV go dark, plus control safety and load handling systems. Today we focus on 4: travel, power, comms, and scheduling. Let's look at wheel wear. There are several kinds. The most common is tread wear. The PU or rubber tread thins, or the metal tread develops grooves. Flange wear degrades guidance. Bearing wear causes wobble and travel. The nastiest is tread debonding, where the PU layer separates from the hub and the wheel slips and judders. Replacement criteria to remember: replace a PU tread once it's worn more than half, say from 20 mm down to under 10 mm. Replace a metal tread when grooves exceed 2 mm. And note, both wheels on an axle must be replaced together, or mixing old and new makes wear uneven. After replacing, the marks on the track tell you whether the alignment is good. Now the conductor rail, the RGV's power lifeline. The system has the conductor rail itself, the collector, the carbon brush, the powered sections and the joints. The most common fault is power loss, usually a worn-down brush or carbon buildup on the rail surface. Brushes are consumables. Check their length every 3 months and replace them once under a third remains. The brush-to-rail pressure must also be right. Too much accelerates wear, too little gives poor contact. And one that's easily overlooked: if a rail joint is uneven, the RGV arcs as it passes, and over time the joint burns out. So inspect and dress the joints regularly. Now, communication problems. The RGV has 4 main comms methods. Wireless Wi-Fi is the most common, wide coverage but interference prone. Busbar carrier needs no extra antenna, but the signal is sometimes unstable. Leaky feeder works best, but costs the most. 5G isn't yet widespread. Comms loss is one of the RGV's most troublesome problems. Troubleshoot in 5 steps. First, check whether the RGV is in a dead zone. Then check the comms module's LEDs. Then measure signal strength. Wi-Fi should be better than -70 dBm. If that doesn't fix it, restart the comms module. Finally, check for new interference sources. From experience, the top 3 causes are AP roaming handover failure, module overheating and locking up, and a loose antenna connector. Now, scheduling deadlock, a problem unique to multi-RGV systems. In short, 2 or more cars each wait for the other to give way, so none can move. Picture 2 cars meeting head-on on a narrow road, neither yielding. Deadlock needs 4 conditions. A track segment can hold only 1 car at a time. A car holds its segment while waiting for another. The scheduler can't force a car to move. And there's circular waiting. The most common case is 2 cars meeting head-on on a loop. To unlock by hand, Always follow the safe procedure, switch to manual, start from the end of the deadlock chain, move one car at a time, and return each to auto once moved. And keep the speed under 20% while moving. Here's a quick reference table, summarizing the 8 most common RGV faults, sorted into 2 urgency levels. Red marks, urgent faults, power loss, commas timeout, failure to recover after an e-stop, and ignoring scheduler commands. These need immediate attention. Yellow marks, ordinary faults, noise stutter, poor positioning, pick-put failure. These can go into planned maintenance. Print this table and post it on site so operators can find the right fix from the symptom without waiting for an engineer each time. RGV preventive maintenance has 5 tiers. Daily inspect the appearance, listen for noise, check the safety devices. Weekly clean the conductor rail and brushes, check wheel wear. Monthly, measure tread thickness and brush length. Recheck positioning. Quarterly, replace brushes, check bearing play and rail joints. Annually, a full overhaul. Replace worn wheels, calibrate addressing. For spares, brushes and travel wheels are critical items to always stock. Never wait until they fail to buy them. Keep a spare comms module too, because if it fails the RGV goes dark. Now the RGV's battery and charging system. Many people overlook this, but it directly affects the RGV's runtime and battery life. On battery type, more and more RGVs use lithium, low maintenance, but the BMS still needs checking. For charging strategy, remember that shallow cycling beats deep discharge. Daily, check the charge LEDs and the terminals. Monthly, measure cell voltages. And for lead acid, the electrolyte level. The charging station contacts matter. Poor contact is the most common reason a battery won't charge. One figure to remember, good charging management can extend battery life by more than 30%. Now the RGV's track and limit devices, the baseline for safe operation. Track inspection focuses on 5 things. Straightness checked quarterly by taut line, joints checked monthly for flushness, fasteners retorqued monthly, the track surface cleaned weekly, and track wear measured semi-annually. For limit devices, test the travel limit switches monthly for reliable triggering, check buffers for aging and leaks, clean the index plates monthly and check the end stops are firm. Note an uneven track makes the RGV judder and accelerates wheel wear, while a failed limit risks the RGV running off the track. This page covers RGV safety procedures. On the left are the 10 prohibitions. The first 3 are red lines: no entering the travel zone while running, no bypassing safety devices, no overloading. On the right is the repair safety flow: lock out and tag out before work, use the pendant in manual mode below 20% speed, and notify the control room to pause scheduling before entering the track zone. You might think the RGV looks less imposing than the stacker, so less dangerous? Not so. Wow, it moves fast, runs on the floor where people are nearby, so the risk is real. Remember this: the RGV can wait, safety can't. Here's a very representative case. An RGV broke down 5 or 6 times a day. A manual reset fixed it each time, only for it to recur. Replacing the brushes didn't help. Finally, they found a thick layer of carbon dust on a mid-section of the conductor rail. Seary dust from long-term brush friction had built up. With the humidity, formed a poorly conductive carbon film. Wherever the RGV reached that section, the power failed. So why did a reset work? Because the restart surge briefly punched through the film, but once the car moved on, the film reformed and the power cut out again. The fix was simple: thoroughly clean the rail. The lesson: cleaning the conductor rail matters more than replacing brushes. Let's recap today's key points. 1. Travel wheels where fastest replace at half-worn tread, and both wheels on an axle together. 2. Cleaning the conductor rail matters more than replacing brushes. Regular cleaning prevents most power faults. 3. Remember the 3 causes of comms loss: AP roaming, module overheating, loose antenna. 4. Unlock scheduling deadlock safety first. From the chain end car by car. 5. Run a 5-tier preventive maintenance plan. 6. Keep your spares well managed. That's it for today. We covered RGV types and structure, wheel wear inspection and replacement, conductor rail power maintenance, comms troubleshooting, handling scheduling deadlock, plus a handy quick fault reference. Next episode is the stacker's servo drive. Cooling maintenance and parameter backup, something many maintainers overlook, but which is very important. And before we close, at the end of the course, let me introduce our core business. Lai Shili Vietnam team specializes in providing logistics automation equipment maintenance services for local Vietnamese enterprises. We have a dedicated local service team, which is much more efficient than remote coordination. If you have any needs, feel free to contact us for consultation. Thanks everyone. See you next time.